What we want to see is if something can rearrange to make a more stable carbocation. So we know that the rearrangement can only occur from a group attached to the positions right next to that carbocation. So what groups do we have? On this one we have a CH3. On the left, my red groups here, and an H. On the right, we have all H's. Now, the only things that can migrate are the groups attached to the adjacent carbons. Either side is possible. We need to look at what possibilities we produce when we migrate one of those groups. Can you tell which one is going to produce the most stable carbocation?
Hydrogen shifting over from the
Red or blue?
from the red.
The red hydrogen, right. Because if we move that one, what we're going to get is we still have the CH3s on there. We now have the red H attached here. We already had two H's on there. Oops, no, we didn't. We already had one H on there. And so we now have two H's. But what's the charge left behind on the carbon that the H left, the red H left? That's a plus. And so we went from a secondary carbocation to a what? Tertiary carbocation, which is more stable. Now, if we had moved the blue one, a blue H, what would we have gotten? What carbocation? Primary, secondary, or tertiary? Primary. And that would be less stable, so that's no good. If we had moved the methyl group, one of the red methyl groups, what would we have gotten? You'd get a secondary one again, and you'd have the same stability. So that's not likely to be an occurrence, yeah.
Are you allowed to move the methyl groups?
Yes, you can. It turns out that you can move either an H or an alkyl group or even a benzene ring. And we call it a hydride migration when we have an H move. Why hydride? What's the IDE ending refer to? General Chem. When we said chloride, what's that? Charge. Negative. We're having a migration of the pair of electrons over with the atoms. So here we have a hydride migration. That pair goes over to the carbocation. You can have an alkyl group also with a pair of electrons, and you can also do benzene with a pair.
So they don't have to be right next to